Hey everyone, welcome to Homeschool and welcome back to Class 9 Science. I am dealing with chapter number 2, Is Matter Around Us Pure? See, we have already completed 2 videos on a chapter. Video links are provided in the description. You can go and watch it out if you have not yet watched. In my previous video, I started with separating techniques, isn't it? How to separate components of mixture. We have already discussed 4 techniques. Say altogether we have 8 techniques. Under that 4 are over. The first one we discussed was evaporation, isn't it? And later we discussed about centrifugation. And third one was, sublimation. And fourth one was separation of immiscible liquids. Immiscible liquids in the sense the liquids which do not get mixed up with each other. So such liquids to separate, it's very easy. We will use a special instrument called separating funnel. So that is what we have discussed in my previous video. And coming to today's video, let me complete remaining 4 important separating techniques. After that, we will discuss about physical changes, chemical changes, and let us understand about element and compound. So with this, I am completing a chapter. So watch the video till the end. I'll be covering every concept of the chapter. Fine. And coming to the separating techniques, the 5th separating technique that I am discussing here is, this is our 5th separating technique, which is nothing but chromatography. So this technique is called chromatography. Okay. Say in Greek, chroma means color, right? So here, using this technique, we can separate colored components. Clear? So what is chromatography? It is a technique used. So this technique is used to separate what? Colored components. Okay. So if 2 colored components are mixed together, in case if you want to separate them, right? So we can always use this chromatography, right? Okay, example I will show you. In case if 2 colors are mixed together to form a dye. Imagine you have a dye which has got 2 colored components, right? So you want to know what are the 2 colors present. For example, let me take a dye as black ink. Okay, black ink. Say this black ink not only made up of only black color, it may have little amount of blue color also. Okay, so whatever the black ink that I am telling, you may think that there is only black dye in water. But no, along with black dye, you may have little amount of blue dye also. But to look at it, it looks only black, isn't it? See, that's what we will try to identify whether you have only black dye or along with that do you have a blue dye also. So if you want to check this, you can always go for this chromatography. Okay, so what we do in chromatography is we take a thin filter paper. So this is a very special type of paper. Okay, special filter paper. Right. So here just 1 centimeter above or 4 centimeter above. Okay. So if you are taking a long filter paper, 4 centimeter above. If you are taking a short filter paper, just 2 centimeter above, you draw a line with pencil. So here you put your ink. Say I am trying to test black ink. I am trying to test whether only black color is there or some blue color have mixed up. This is what I am trying to test. Okay. In case if blue color is mixed up in this black ink, I just want to separate blue color from black color. right? So that is my aim. So for that we took this filter paper and we have drawn a line little above to the edge, and here I have added a drop of this black color ink. And I took this filter paper and I will introduce this in a beaker of water. So I took a water here and I will introduce the same filter paper. Okay, I'll dip the filter paper in a water. Okay, say I'll dip the filter paper in such a way that the drop that I have added here is dipped into a water. It is touching water. So what happens as it has dipped into a water, the ink starts going up. You know, water level, the filter paper will try to absorb water. So what happens, the water level will rise up. Imagine, you can test this at your home also. You dip a paper in a water. What happens? Water level will go up, isn't it? Water level will try to go up in the filter paper. As water level rises up, you know, the colors which are there in this drop of ink also will get raised. Okay, so somewhere here you will observe a black color, or somewhere here, you know, you will observe a black dot there, and you will also observe a blue dot here. Okay, see here, actually this ink was mixed up with two colors, black and blue. How did I get to know that there are black and blue colored dyes? It is by this chromatography. So when I dip this filter paper in water, water level will rise up. Along with the water, the dyes also will move because the colors are soluble in water. Since they are soluble in water, along with the water level, the colors are also rising, and you know, depending upon their solubility, the black color may be soluble more, blue color is less soluble. That's why black color have moved further almost to the top, whereas blue color remained here only. Right? So solubility of components is different in different solvents. Here water is a solvent. Okay, say these are the two components. Both are not soluble to a same extent. Black color is more soluble, that's why it has moved up. Blue color is less soluble, that's why it has stayed there. Okay, so what is the major principle involved here? Components gets separated. Components gets separated according to, this is very important point, according to their solubilities in water. Okay, so if both are soluble in a same extent, both would go together in that water, isn't it? Both are not soluble to a same extent. Black is more soluble, that's why it is going according to water. Say water level has reached here. Okay, paper absorbed water and water level is coming up, it is reaching here, right? Along with the water, black color also moved to the top. That means black is more soluble in water. Okay, so depending on the solubility differences between the components, you are trying to separate the components, you know, using this chromatographic technique. Okay, so specially this technique was used to separate the colors. So that is why it was called as chromatography. Okay, so what are the applications of chromatography? If I have to discuss applications, that is uses of chromatography, I can say it is used to separate colors, colored components. It is used to separate pigments. Okay, we can separate pigments. Pigments are nothing but different colored components that can be present in flowers, colored flowers. Okay, and it can also be used in the field of medicine to separate drugs. Okay, it is used to separate drugs. Okay, in medicine, right? So it has various applications which you will be studying in much higher levels. So now just understand what is chromatography, what is the principle involved, and what are the major applications, right? So that's all about chromatographic technique. And now let us go for, separation of two miscible liquids. If one liquid is completely soluble with another liquid, if you want to separate them, how is it possible? So that's what we will try to understand. See guys, in my previous video, I already told you how to separate two immiscible liquids. Immiscible liquids in the sense, the liquids which are not getting mixed up with each other. They are easy to separate. But here, miscible liquids in the sense what? Liquids which are completely mixed up with each other. Mixed up with each other. Okay, so such liquids are called miscible liquids. Alcohol and water, right? So when you add water into alcohol, they get mixed up completely, right? So like that, there are many liquids which gets mixed up completely. So such liquids are quite difficult to separate, right? So to separate two miscible liquids, we use a technique called distillation. So there is a process called distillation. So there are two types of distillation actually. One is simple distillation, and the other one is fractional distillation. So these are the two types of distillation, simple distillation and fractional distillation. Okay, so let us first understand about simple distillation. Later we will go for fractional distillation. So our sixth method is, so this is our sixth method, simple distillation. Seventh method is fractional distillation. Okay, so coming to simple distillation. In simple distillation, we can separate the liquids which have a large difference in their boiling points. Okay, so this is really very important. This method can be used to separate liquids with large boiling point difference. Large boiling point difference. Okay. So what do you understand by this particular sentence? Imagine I have a mixture. I have a mixture of two liquids. Okay. So this mixture contained liquid A and it also had liquid B. Okay, liquid A's boiling point say around 100 degrees centigrade and liquid B's boiling point is around 170 degrees centigrade. Okay, so liquid A's boiling point was 100, liquid B's boiling point was 170 degree. So there is a large difference in the boiling point, right? What is the difference between 100 and 170? 70 degrees. So 70 degrees is the difference you have between boiling point of A component and boiling point of B component. Say it's a quite large difference between A and B. So such liquids can be easily separated by simple distillation. So for simple distillation, you must understand the condition properly. If you want to separate two liquids based on simple distillation, the boiling point difference between the liquids must be large. Only then you can use simple distillation. Okay. So now try to understand the process here. See, we always heat in distillation. Say we will take an instrument called round bottom flask. This is actually called as, round bottom flask. And we will try to heat this with a Bunsen burner. Say you have a Bunsen burner where the flame is coming and we are heating. In this round bottom flask, I took a mixture where A component was there, B component also was there. A is some chemical, B is some chemical. So two components A and B. Okay. I want to separate A from B. So I want to separate A from B. Both have been completely mixed up with each other. Okay, fine. So here I will introduce a thermometer. You will have a thermometer because you need to check the temperature every now and then. And this is also connected to a condenser. Okay, so there is a condenser here. So this condenser is filled with a cold water. So condenser is opened to a beaker. Okay, so here somewhere here condenser gets opened to one empty beaker, right? Okay, so what is the use of condenser is whenever some vapors passes through this condenser instrument, it is filled with ice cold water. So whenever some vapors come through this round bottom flask and when it enters to a condenser, that vapor will become a liquid, and as a liquid it gets collected in a beaker. Okay, so this is very, very important. So now I am heating. Okay, say A liquid has a temperature. Imagine, suppose this is an example. A has a boiling point of 100 degree. So when I started heating, there is a point at which 100 degree is reached. So in the thermometer, I can be checking a temperature, right? So the moment 100 degree is reached, you will start seeing A vapors. A will get vaporized because that is the boiling point of A. At boiling point, A will become vaporized. So these vapors will come up. First, it will reach the condenser. Okay. So in a condenser, vapor is again becoming a liquid. So as a liquid, it gets collected in a beaker. So in a beaker, whatever liquid you collected was A. Okay, so once you can maintain the temperature 100 to 105, so that you can maintain the temperature for a while, so that all vapors of A will come to condenser. There it becomes a liquid, and as a liquid you are collecting in a beaker. Okay, so now this is how you can separate A from B. Okay, you want B also from this, then you take out this beaker, keep a new beaker, go on heating. The moment temperature reaches 170 degree, B gets vaporized, it goes through a condenser, there it becomes a liquid and it will get collected in a beaker. So that's how A component is separated from B component. Okay, so this is what we call as simple distillation. What is this? Simple distillation. So in a simple distillation, we will use something called condenser. Okay, so this is a flask. I took a mixture. I'm heating. So the moment one boiling point is reached, one component gets vaporized, it goes to a condenser. There it again becomes a liquid and it gets collected in a beaker. So that's how you are separating A from B. Okay, so very, very simple technique, that is simple distillation. Now let us go for fractional distillation. See guys, this fractional distillation is very important and very different. In simple distillation, I said that two liquids can be separated if they have large difference in their boiling point. Now, if two liquids have very, very less difference in their boiling point, then how can we separate? We can separate by fractional distillation. Okay, so fractional distillation is our seventh method actually. So fractional distillation. Very important point to understand here is, here we can separate liquids with less difference in their boiling point, less difference in their boiling points. Okay, so in the sense, when the liquids have a boiling point difference of around 25 Kelvin, 25 Kelvin is actually much less difference. Okay, so imagine you have liquid A, right, which has a boiling point of 100 degree centigrade. You have another liquid B which have got a boiling point around 110 degrees centigrade, right? So if A and B have mixed together, you want to separate A from B. You see, A's boiling point is 100 degree, B's boiling point is 110 degree. So how much is the difference? Only 10 degrees, right? So when you have this much less boiling point difference, then we cannot separate them by simple distillation. For simple distillation, more boiling point difference must be there. You can go for which technique? Fractional distillation. Okay, so in fractional distillation, we use a very special instrument called fractionating column. We have something called fractionating column. Okay, so using this we can separate different liquids which have a very less boiling point difference. So just try to observe the figure here. Say, just like simple distillation, we will take a round bottom flask where we have a mixture of A and B. So we will try to heat from Bunsen burner. Okay, so this is our Bunsen burner, and here a glass tube is introduced. Okay, so there is a glass tube which contains number of glass beads. Okay, so this is a glass tube which contain glass beads. This is what we call fractionating column. Fractionating column. Okay, so this is a very important instrument here. Now this is connected to condenser. This is connected to condenser. Okay, so I am actually drawing a very rough figure just to make you understand. Okay, so and you can keep a beaker here. So what happens is, as you heat, imagine A liquid has boiling point 100 degree, B liquid has boiling point 110 degree. As you heat, first A liquid will boil. First reached temperature is 100 degree, right? So when you keep a thermometer, you can check temperature first reaches to 40, 50, 60, 70 and then 100. So the moment temperature reaches 100 degree, A vapors will come and they will go to this fractionating column, and on the beads it gets condensed. Okay, so on the beads A liquid will get condensed and A liquid gets separated here. Okay, and further heating B liquid will go, okay, and it will go little higher, and it gets collected here, right? So the beads actually provide a surface for the vapors to get condensed, right? So the liquid with less boiling point will get condensed first. Okay, in this area here only it will get condensed and it will stay, whereas the next liquid with high boiling point will reach further higher and here it gets condensed, right? So now that's how here only they got separated actually, right? So that is how you can separate one liquid from another liquid which have a very less boiling point difference. Okay, so actually this particular fractional distillation can be used to separate various gases from air, right? Say for example, the moment I say air, it is a mixture of oxygen gas, nitrogen gas, hydrogen gas, etc. Right? So I want to separate oxygen gas from all of them. So I can always go for fractional distillation. So what is the first step I will do is, I'll take a air and I will convert this air into liquid. Okay. So how do we convert air into liquid? By cooling. And when you supply high pressure, when you apply high pressure on air, air will get compressed. Okay, and at low temperature, high pressure and low temperature condition, our air will become liquid. When you compress with high pressure at very low temperature, our air gets converted into liquid. Now this liquid has many gases, right? So this, from a liquid you are separating oxygen, nitrogen, hydrogen, by fractional distillation. So FD in the sense fractional distillation. Okay, so this is how using fractional distillation we can able to separate various gases from air. Try to remember this point also, right? So this is how we can do fractional distillation to separate various components of air, and also you can separate the liquids which have a very less boiling point difference. What is important to remember here is, for fractional distillation we use something called fractionating column. Okay, so this is all about the two types of distillation. And now we will try to discuss the last separation technique, that is crystallization. This is also very important and very interesting. See, this crystallization is a very different technique. This technique is mainly used to purify solids. Okay. For example, you have got a salt from sea. This salt would have had lots of impurities. So your aim is to separate these impurities. Okay, then we can use a technique called crystallization. Right? So what actually we do in crystallization is, this impure salt, we will take it in a beaker and we will try to dissolve in some solvent. Okay, so we will try to dissolve that impure salt in some solvent. Okay, fine. And you will try to heat this. When you heat this, you know what? Our salt plus impurities, both will dissolve. Okay, so both dissolve very nicely. And after that, immediately you will cool. What you have to do? You will cool this liquid. When you cool this liquid, you know what would happen? Only pure salt will reappear. Okay. So when you cool this, what happens? Pure salt crystals reappear. And what about the impurities? Impurities are in dissolved form inside the solvent. Okay, so here what is the principle that we follow? Principle is that impurities must be dissolved in solvent. Okay, in both cold and hot condition. Okay, so you have to select a solvent in such a way that impurities must be dissolved. They must stay in solvent in both cold and hot condition. So let me summarize the process what we have done. Impure salt is there. My target is to remove the impurities. Okay, so I took that impure salt and I dissolved in a solvent. Selection of solvent is very important. Okay, I should dissolve it in a particular solvent. And on heating, both pure salt and whatever impurities are there, both of them must dissolve very nicely. Immediately, I will allow this for cooling. Okay, so on cooling this solution, only salt crystals must reappear. Okay, salt should not dissolve on cooling. Only impurities must be dissolved. Okay, since salt is not soluble in cold condition, salt will reappear as crystals. Whereas in this salt crystals, impurities will not be there, because impurities are soluble in a solvent even in a cold condition. That is why impurities will not come up with salt crystals after cooling, because they are dissolved in water. Once they dissolve in water, it is dissolved only in both hot and cold condition. So this way we are separating impurities from pure solid. Okay, so this crystallization is mainly used to purify solids. If any impurities are there, to remove that, this technique is used. So for crystallization, selecting a suitable solvent is very, very important. You should select a solvent in such a way that, your impurities must be dissolved in solvent both in cold and hot condition. Okay, and salt crystals must reappear on cooling. Okay, so this has to be the condition for crystallization. Okay, so more details of this you will be studying in much higher levels, right? So that is all about crystallization, right? So with this we have completed all the 8 techniques of separating the components from a mixture. So now let us quickly understand about physical and chemical changes. See here, it's very important to understand the meaning of the word physical change and chemical change. Physical change in the sense only the state of a compound is changing. Okay, so what is changing? State of a compound or a molecule changes. So what do you mean by state of a compound or molecule change? State, physical state in the sense solid, liquid or gas. So if you take up ice, right? Ice is in solid state. Ice is in solid state. If you take liquid, water. I am taking water. Water is in liquid state. And if you take water vapor, water vapor is in gaseous state. Can you tell the formula of a compound present in ice? It is H2O. Can you tell the molecules formula of molecule present in water? It is also H2O. Can you tell the formula of molecule present in water vapor? It is also H2O. So chemical formula is not changing. So what is not changing? Chemical formula is not changing, right? Only the physical state is changing. Okay, so ice on heating, you will get liquid. Water on heating again, you will get vapor, isn't it? So when you heat something, particularly when you heat ice, solid form converted into liquid form. This on further heating, liquid form converted into gaseous form. Okay, so but here molecular formula has not changed at all. So such a change is called as physical change. Very simple. Physical change is a change where only physical state of a compound changes. Which changes? Physical state of a compound. Physical state in the sense whether it is solid, liquid or gas. So physical state, physical appearance will change but not the chemical nature. Okay, so in all the 3 physical states, chemical formula is H2O itself. This has not changed. Only appearance has changed. Such a change is called as physical change. Okay, fine. And coming to chemical change. Chemical change is nothing but occurrence of chemical reaction. Occurrence, that means happening of chemical reaction is called chemical change. So here actually formula of a compound will change. Formula of a particular compound will definitely changes. Okay. So what do you mean by formula of a compound is changing? For example, okay, I will burn magnesium. Magnesium symbol is Mg. Magnesium I will burn with oxygen, right? So I will get a new compound MgO, right? So Mg, initially it was Mg, but after I burn it has become MgO, right? So Mg is different, MgO is different. Okay, Mg has different properties and reactions. MgO has different properties and reactions. Okay, so when you do some when you do some heating or when you do some burning, if a molecular formula itself is changing, then such a change is called as chemical reaction or chemical change. Okay, so this is the major difference between physical change and a chemical change. Clear? Fine. And coming to the last topic, understanding about element and compound. Okay, so you have something called element and compound, right? So this difference I have already told in my first video, isn't it? So element is what? Element is a pure substance made up of same type of atoms. Same type of atoms. Okay, so for example, copper is an element, iron is an element. If you take a iron piece, all over the iron piece you have crores of atoms which look similar. All are iron atoms only, right? So it is a pure substance which is made up of same type of atoms is called element. Okay, so again these elements can be divided into metals, non-metals and metalloids. Okay, so metals are what? Metals have some very special characters. Okay, so metals, example, I can give sodium, potassium, all these are metals. They are shiny, sometimes they are soft, they are hard, and they are ductile and malleable. I mean, you can make them into thin wires or you can make them into thin sheets. They can conduct electricity. All these are properties of metals. Okay, and you have non-metals. Non-metals are exactly opposite to metals. They do not conduct electricity, they are not malleable, they are not ductile, they are not shiny. Okay, so all these are the properties of non-metals. Coming to metalloids, metalloids behave like metals sometimes and they behave like non-metals also, right? So these are some different types of elements. Elements can actually classified into metals, non-metals and metalloids, right? Okay, and coming to compound, see, compound is also a pure substance. Compound is also a pure substance, but it contains different atoms. Different atoms in a fixed ratio. This is very important. For example, you see H2O. You take a beaker of water, guys. So everywhere you have H2O molecules only, right? So top, bottom, onto a side, everywhere you have this H2O molecule only, right? So it is also a pure substance, but here this one molecule has two different atoms, hydrogen and oxygen, but they are combined in a fixed ratio. Can you tell me what is the ratio here? Hydrogen 2 atoms, oxygen 1. So 2:1 is the ratio. Say hydrogen and oxygen have combined in 2:1 ratio to form one water molecule, right? So it is also a pure substance, but different atoms have combined in a fixed ratio to form a pure substance, which we call it as compound. Okay, so having an idea about the difference between element and compound is also very much important and essential, right? So with this I am completing a chapter. Say I discussed everything. All the separating techniques are very important to understand, and try to understand what is the difference, when to use what technique. Okay, so that's all about the chapter. So see you soon with the next chapters. Already I have 7 chapters in a channel. I mean, I have covered till the chapter motion. Okay, so remaining chapters are yet to come, and keep watching our channel. Do subscribe to learn the concept in a easiest way. Thank you so much.